My name is Krzysztof Sroka. I'm from Wrocław, where I lead Flutter Wrocław and a couple of other things. I'm a speaker, work as a Flutter developer freelancer, organize meetups, organize a Flutter Europe conference with guys over here and other people from Poland. I'm also hiring. If you want to work on Flutter in the awesome town of Wrocław, and especially if you have commercial Flutter experience, talk to me, and we might have some opportunities to share. This talk will be about not shooting yourself in the foot. It's basically some advice on how to make sure that you don't slow down your application unintentionally. It will also present some ways to debug this, but I will focus mostly on the advice part. But first, we'll need to go through some of the basics. So, why do we care about this 60 FPS? People actually, oh no, this is terrible. It's probably me. Yeah. Sorry, that was my phone. Why do we even care? Actually, nerves in our eyes can fire up to 1,000 times per second. So 60 FPS is nothing to them. We can see flashes that appear shortly, like in 1,000th of a second. And we can actually, it's not like theoretical capabilities, we actually do this. However, the brain is pretty good at filling the gaps. So we've been to the movies, seen to the movies that are shot mostly at 30 FPS, and you have a pretty good impression that this is real, right? Our brain is pretty good at filling the gaps, so 60 FPS might not be the top edge of human capabilities, but it's pretty good. There are already screens that do 120 FPS and 240 FPS, and this talk will not be about the 60. This talk will be good for any constant that you find, over 9,000 even, if you like. But it will be about Flutter and how it works and how is it so fast in a way. So Flutter is, so how Flutter works. There are two main threads that work on bringing the UI together in Flutter. The first one is a UI thread. So this is a thread that the framework, the Flutter code uses. So most of the work we do is in this UI thread is going to be executed in UI thread. And there's a GPU thread, which is basically the C++ engine of Flutter that's running underneath. And it's really hard to actually even debug that part. So it's going to be rather unlikely that you need to mess with this. But what you do in a UI part will affect the GPU part. So we need to keep this in common. And the Flutter, actually, if we fit both of the executions, so Flutter first does the framework thing, then once it's done with the framework on the UI thread, it goes to the engine on the GPU thread. And if it completes one of these cycles, so every time this vsync event happens, I'll tell you in a moment what's vsync, this cycle starts, and if we manage to actually do that work in 16 milliseconds or less, we'll have a nicely performant app in 60 FPS, very smooth, with all the nice features, and people will think, oh, this is really good, well-written app. Congratulations, developer, have a coffee. The vsync, I didn't mention the vsync. Vsync is an event that's basically tied to the refresh rate of your screen. So Flutter goes to the hardware, knows how to tie into the interrupts that say, oh, I'm ticking a clock on for the screen to refresh, and it starts its work at every time this vsync event happens. An alternative to this is that. So imagine that we are a bit sluggish in our app, and we cannot finish both the framework and the engine part in under 16 milliseconds. However, if we do that under 32 milliseconds, the app is still going to look smooth. However, it's going to have a very minimal delay in responding to everything in gestures. But that's 16 milliseconds of delay, let's say, of this extra milliseconds that you take. But still, if we complete every cycle in twice the amount, so for about 32 milliseconds, we're still going to have smooth UI. It's just going to have a little bit of latency. And to understand how Flutter achieves that, we need to understand how Flutter works internally. There's a common misconception that Flutter is all widgets. It's a misconception shared by official documents, by many people around, and it's very easy to actually believe in this lie. Most of the work we do is widgets. However, elements, which are entities backing the widgets, are the central part to Flutter. So every widget actually has an element associated with it, and the framework, when it works on elements primarily. Widgets are a configuration for these elements only. But there's also render objects. So some of these elements will be a subclass of a render object element, and we'll actually create a third tree of render objects. Render objects are classes that know how to draw the widgets. They know how to position them, how to scale them, they know how to color. They have access to the canvas, and they know the basic operations that Flutter actually does to print its own widgets. But not every element and not every widget will have a render object. Actually, most of the widgets that we write won't have render objects. So there are basically like three categories of widgets. I call them, on the left-hand side, you can see the blue objects. These are stateful, stateless widgets, which is what we use the most in our day-to-day work. There are also inherited widgets and parent data widgets, lesser known widgets and lesser used widgets, although if you use provider, you use them. And these get to have an instance of the component element, which doesn't have a render object. Simply, it manages different elements to do something extra, pass the data, configure these other elements. And many of the widgets that the Flutter library provides are actually render object widgets, or subclasses of render object widget, which have a render object element, which in turn has a render object. And the render object knows how to paint everything. So including padding, center, row, column, text. Text is a special kind of thing because it has a dedicated rendering scheme. But other than text, most of the things that we use from Flutter SDK are render objects. But how does it work? I mean, what does it do? And actually, element, as I said, is the centermost piece in a Flutter framework. And when we speak about having a quick app, we need to speak about how the elements work. Elements have this life cycle of being mounted somewhere in a tree, and then a continuous rebuilding of it, including marking as needing to build, and the rebuild itself. And the end of a widget, when it's no longer needed, or end of the element, when it's no longer needed, is done by unmount. So if you ever wrote a stateless widget, and sometimes you have asynchronous operations that might return when the widget is no longer there, sometimes you need to check if the widget is mounted, which basically translates to if element is mounted. If it's not, basically it's no longer there. It doesn't even have how to render anything on a screen. And the mounting part is really hard. So actually, before the element mounts, it needs to instantiate everything. And if it's like a tree of elements, it needs to instantiate the whole tree. That's what happens on the app start. Like there's no tree at all. We instantiate the root widget, which in turn builds and instantiates another widgets, which return into elements. That's the hard part. And because of that, Flutter actually has a warm-up frame to make sure that this tree exists before we start doing proper work. But yeah, mostly we are concerned about these two in the middle. So when a vsync comes, what Flutter does is tries to go through all these elements that have been marked to be rebuilt and rebuild them. First, it evaluates all the elements and tries to arrange them in a new tree. Then it does perform build. Sometimes it's a widgets build that's get called, but that's a worst case scenario actually. No, there's worst case scenarios, but this is a bad case scenario if a widget actually needs to be rebuilt. So when an element gets rebuilt, it tries to update the widgets. These are basically equivalents of how the framework works. Widget, when it gets to rebuild, it updates its children, which in turn do end up being rebuilt. And this is how the life cycle of elements or tree of elements happens. And we would like to limit how many elements need to be rebuilt on every vsync, right? We need to see what's actually in the update. Maybe the update is going to help us to see how can we optimize this, how can we make sure that Flutter doesn't rebuild more than it needs to. Now it's actually update child, but how to make not the update being called on child. First of the cases in update child is when we have a new widget, like we've run a build somewhere. We have an old instance of a widget and a new instance of a widget. If a widget was a const widget, we finish here. We don't update anything. We say, okay, this is the same widget. We gave it the same configuration, and hence all the things are the same. There's a special thing happening with the state. State gets attached again to that new object, but nothing happens with respect to how the widget, what happens to the tree under the const widget. And you might think const widgets are just this simple thing like, oh, const text or const padding or some sized box. That's const. But actually, most of the widgets can be const. And I'll show you how later. Now, then it's called, if the widget is different, actually the instances are different, we check if we can update one widget to another. So we have this element somewhere up in a tree. Yeah, somewhere, let's say here. And we see, oh, my widget changed. If a widget is of the same type and has the same key, the child gets updated. This is not the best case, but it's common case, let's say, because most of the time, and we would like to have this case if we need to update a widget, most of the time widgets remain the same of the same type, and most of you don't set keys on your widget. So that's good, because null equals to null, so it gets to this point. One special case is for global keys. So if we have a global key set to a widget, we retake that widget from elsewhere. And the point is just that the widget needed to be removed from a tree in the same cycle. So we see, oh, was that widget somewhere else before? If it was, but it's in a new place, we can just reattach the whole widget and its subtree to a new place. And we update that again. But when everything else fails, that's the worst case scenario actually. So Either keys don't match, the widget type doesn't match, there's no global key, or widget isn't const. This happens. There's a whole new subtree of elements being built. So we start with the elements, and then we clear everything down from that point. Of course, there might be like global keys down there, which simplify or things, but if this fails, if we cannot really match the old widget and the new widget and somehow update them, we rebuild the part of the tree that's underneath. And this is expensive, because this creates lots of instances of the other objects, needs to reattach some tree. When we update, it's easier, because we preserve the instances, some of the state is there. And how does setState connect it? Where's the state actually, right? I like this because there's no state. The state, this is a lie. Whatever we do in a callback inside is just a random function. The setState looks like this. It calls the callback and marks the element of a widget as needing build. There's nothing else, totally. So there's no state object. People who have been writing in React Native are used to, oh, there's this JavaScript object lying there, and if I set setState and, I don't know, update some fields, it's going to compare these fields. No, there's nothing like this. There's no magic at all. Maybe there's magic in not having anything at all. It's just executing something and marking as build. So, with that being said, let's go into the juice. Let's optimize. Of course, the first red flag, don't optimize if you don't need to optimize. I mean, if premature optimization is the stepping stone on the road to hell, basically, until you have problems, you don't have problems. Don't treat your app as unperformant, because that will lead you to doing things you don't really need to. Flutter is pretty good at being fast. And if you just try to hunt down every case where you can optimize, you're just going to spend time on nothing, literally. Some basic stuff. So as I said, use const where possible. It's going to be best case scenario if you use const. Don't reassign keys, and don't change a tree, so that this comparison of, hey, this is a widget type and the key actually succeeds, and we just update the widget. And use global keys like only if need to. There are rare cases where you need to or want to, but yeah, this is like a this is like a final thing you can do if you really want to transfer part of your widgets into a new place, reattach them, but usually you don't do this. It's a really narrow use case. First thing you should do is rethink setState. So setState has this unfortunate effect that when you call it, it marks the element as needing build, and potentially it can cause a cascade of rebuilds and updates in the whole subtree. And as you know, widgets are plenty. We compose widgets all together all the time. And if you do that in close to the root of application, you might end up with something very slow, especially if your widgets take time to build. So one common mistake that people make, is it visible? Okay. Is that they unnecessarily set state. If, for example, you have some new value and you want to set state because, I don't know, it's a color slider. First, check if you actually need to do this. So if the old value is equal to the new value, you absolutely don't need to. Or if the value doesn't pass the threshold to trigger a change, don't do that, because setState is not, as I said, there's no state really. It's not going to find out that you've changed the value of some field. It's just going to run. without any discrimination. So if you have some checks and if you have a condition when you want your UI to rebuild, you put that around the setState. And as I said, setState just runs the callback immediately. So this is also possible, but it's a little bit discouraged because it's harder to find what you actually changed in your states. Const widgets are a fun thing. So once upon a time when I first gave this speech, I was thinking, oh yeah, const widgets are very, very use case. But then obviously someone told me, no, this is not the case. We usually have this, right? We usually have a widget. It's a stateless widget here, but it could be stateful widget. We pass it some data, the data that it's going to get to render itself, right? We want it to be there, and our build method is going to use that. But what this means is that this widget cannot be const unless the data is const. But usually it isn't. It's something that we change. Let's say a value of a slider, right? So we pass a value parameter to the slider or value to the preview and see what's that. Actually, a preview was a good thing. But what we can do instead is use the inherited widgets or provider, which uses basically the same, or any kind of widget or state management that uses context to pass data, and have an empty constructor, and instead get the data from an inherited widget somewhere up the tree. So when we do this, we ask up the tree, or we don't actually ask up the tree, I'll explain. Hey, I need data, or I need to use the object from up somewhere of this type. So I have some type of widget, please fetch me one. Actually, it doesn't need to go up the tree. What is in a context is a hash map of every type of inherited widget to its value, to its instance, and it gets updated in every build method. So if we have child of inherited widget, it's going to just add a new value to the context and pass that to the build of its child. Like if we have children of inherited widgets. So this is basically constant time to fetch data from context, from inherited widgets, from provider, which basically uses the same thing. And in this case, basically it's just like side-loading data for our widgets. We have some more control the way we do this, so actually the widget itself can control a little bit how it does it. However, when we call inherit from widget of exact type, that widget that gets returned will remember which element actually called that function, which build, and will know to rebuild if themselves thinks, oh, I've changed inherited widget data. There's more details to this, but this talk is limited in time. So if you want to have more details on how does it work internally, just grab me after the talk. So maybe these two pictures don't match exactly, but we fetch some data from up, and the inherited widget remembers who has fetched that data before and triggers rebuilds only in these parts. So instead of having, let's say, here a widget that controls the data and does rebuild of everything. Yeah. That's the wrong button, no? Inputs, right. That's me. Sorry. Going back. And instead of putting the data somewhere in this, I'm used to that because I don't have a. Does it have a pointer actually? It does. Yeah. Instead of putting data here and making sure, this is going to set state and rebuild whenever data changes, we can put it somewhere above and have a widgets themselves ask for data, right? This is going to be optimized because, for example, this widget in a tree might not need that data at all. And if we put, for example, provider here, we can skip all these stupid parts, but don't use data and just update what we actually need to update. So when the update comes to, when the update of that inherited widget happens, it triggers updating everything that asked for data. But as a person over there said, how do we discriminate, like, if we want part of the data? If we have 3 sliders and each of the slider uses just one of the colors, how do we make sure that we don't rebuild all the sliders at once? If, for example, red changes, we don't need to rebuild green slider at all. We can do like this. We can put more inherited widgets, and every inherited widget will be responsible just for 1 color. Or we can have inherited model, right? An inherited model has something called subject, and instead of subscribing to the full data set, you can subscribe to a certain subject, which is a string, and inherited models internal implementation needs to figure out, okay, for this string, this is the data I want to pass down. And these are the widgets that ask for this subject. So we can split it like this. There are some other ways and other state management libraries that make it a little bit easier because, as my predecessor said, this isn't very easy to use. It's a little bit too long method names and some details that you need to understand to make sure that it doesn't do the wrong thing. All right, another thing, do not ever change a tree, or very rarely change a tree. Imagine this, like we have a button that turns some widget visible or invisible, like hidden or not. It's another mistake that we should, for example, use here, a wrapper, visibility, and set visibility to false. It can be any wrapper, but if we do like, hey, I have a condition under which I want to wrap my widget into something, and this gets randomly changed, or this gets changed whenever user clicks something, for example, we will trigger a full rebuild of that element tree from this point on, because the data types of wrapper and widget will not match when the update comes. So most of the widgets provide, I think all of the widgets that have this kind of on-off functionality in the Flutter SDK actually provide a way to specify a Boolean parameter, like enabled, visible sometimes, or something else. And this way we can limit the changes to the tree to somewhere really low that actually is close to the render object of it. So if something's invisible, it eventually needs to rebuild because it needs to disappear or appear, but try to not change this anywhere high in the tree, like not change the structure. Use instead these wrappers. Sometimes we have to do this in things like future builder or stream builder, but this happens rarely because this happens once, usually, where we don't have data and switch to having data. This one time we'll need to rebuild because there's a whole new plethora of widgets coming. But if we switch this, if this condition changes very often, we'll have a very slow app. Don't split too far. Render objects are a little bit expensive. So if you can use some shorthand render objects instead of shorthand, not render objects, widgets instead of doing very complicated things because, I don't know, you imagine this is better for style or whatever. This creation and handling of render objects is a little bit slow comparing to basically updating a widget. try not to split things too far if you don't need to. var widgets, like, it requires a little bit of inside knowledge, or actually peeking into the code of Flutter, because var widgets like container. And you think, oh, container can do this, that, position, align, add padding, add color, whatever. Actually, what it does, it cascades a widget it needs inside. So you also need to be careful, because this actually can happen with container, because if you decide, oh, padding is 0, or padding is not, or padding is specified, or padding is not specified, it might change the internal structure of a tree, and yeah, you have a bad time, even not knowing that you've done something wrong. You know, this is not the pattern I told you is bad. And yeah, this is one of the things that you also need to pay attention to. So in Flutter, we will not only handle UI changes, right? Sometimes we need heavy data, images mostly, videos, some other transformations that don't happen instantly, and certainly can go over the threshold of 16 milliseconds. So we are able to spawn new threads. So replace this, it should be red, I guess. If you have a heavy function, let's say, that takes a parameter and does something, instead of writing like this, which will make it run on a UI thread of your Flutter application and block the framework from doing all the other necessary work, like cleaning widgets, use the compute method. It's from some Dart standard library, I don't remember, Dart async possibly, which is going to create a new thread and pass your function with all the parameters required to this. To do it off thread, you have a future that will eventually complete, and once it does, you just do whatever you need to handle the widgets. But yeah, the compute will actually run somewhere else and not block your UI from refreshing. So if you have, for example, stuck the UI somewhere, stagger inside your application, it might be that you are doing too heavy things, you are doing some processing that's basically too slow, and you should do that on another thread. This often happens like when you have a circular progress indicator, and you see just a small pixel in the middle. And wonder, why is it just a small pixel? I want a circular thing. Why doesn't it work? It's because somewhere something does a heavy processing that it shouldn't on a UI thread. But there might be other reasons. So don't always blame that. And I didn't tell about render objects a lot, but there's one useful hint there. If you have, first, how does the render object itself decide to update? Because render object is a different tree, but sometimes it changes. For example, we switch orientation, we pop up keyboard, and even if the widgets don't change, right? There's something changing the layout of our widgets. So let's assume we have a small widget here, but for whatever reason needs to change its size. Theoretically, what can happen is this widget will eventually notify its parent, and this widget will notify its parent that they also need to be redrawn on a canvas. And once this one here, super parent, gets to be redrawn, everything else underneath it will. So there's this cool thing called RepaintBoundary that protects parts of UI from layout changes of unrelated things. Imagine you have like a closed container, it's always the same size, but inside it, there's some magic going, like widgets change size over time. But you know it's not going to ever affect anything outside of that container. You can put it in RepaintBoundary. This will mean that if you have a just small change here, this is not going to propagate up past RepaintBoundary, So this widget will be like a boundary widget, which is basically what it says. And it's not going to receive relayout requests from its parent. There are things that actually repaint requests. I'm confused two things. Layout are different things, and layout actually avoids this. But painting itself without changing size will affect this cascade of operations. But RepaintBoundary will prevent us will actually make us scope the changes to some part of our subtree. And now, if now some ways to get help. If you see our app is sluggish, I don't know what's happening. How to debug what I have? First of all, in debug mode, a mode that we run all the time with hot reload and everything, we have very slow performance because there are assets, there are checks that Flutter makes, and all of this is stripped in profile mode or release mode. So your debug build can be very slow, but once you build for production, it might be super fast. So first you verify that in profile mode, which is very close to release in terms of what happens in the code. It just provides extra data for profiling. But it doesn't do any checks, any debug checks or any heavy stuff that actually in development apps do. The other thing you do is you run a performance overlay. You can either do that from your IDE if your plugin supports this, or you can, for example, add this parameter to your app. I think Material Cupertino app supports this. It will show you a nice graph. On the top, there is a GPU thread, and on the bottom, there is UI thread. And each of these jumps is basically some redraw or starting a new vsync, you can see here. But some of these will be red. I don't think I have anything like this happening, unfortunately. But you can monitor, basically, going through your app, you can monitor when does something wrong happen, right? At what interactions the app starts getting slow. Maybe it's multiple interactions. Maybe there's some leak or something that you do extra. So this is very helpful to observe. There are lots of flags in debug mode that you can check. So of course debug mode is going to be slow, but it also has these checks, and there are plenty of them. Actually, going through the code, you can find multiple of these. They usually start with debug something, and this will print out to your console information about certain behaviors, like when a particular when you schedule a build for some element, what was the stack trace? And what is the stack at the moment that you schedule a build? Maybe that's going to help you debug why your element that doesn't change visually gets rebuilt. What's triggering that? Sometimes it might be somewhere deep in the SDK because you passed it as a parameter somewhere, and that's how it works. And there's lots of these that can help you debug these stages of a framework is going through and what triggered what. Repaint Rainbow is I saw about RepaintBoundary. Repaint Rainbow helps you visualize what gets repainted. So it wraps every. It's also in debug mode. So everything starting with debug is only available in debug mode, but it wraps every widget you have in this colorful border, and the border color changes with let's say as a rainbow colors. It changes whenever the widget wrapped needs to be repainted, or render object that's backed by a widget there needs to be repainted. Actually, it does some animation. You can see the color changes, but maybe it's hard to notice. But the full app gets rebuilt only because this text changes. The app bar gets rebuilt, oh, it gets repainted. This button gets repainted. This button actually might be useful because it has some shade when you press it. But certainly you can notice, hey, if I'm doing too much, I can see that on Repaint Rainbow. Maybe that's a point, maybe that's a place where you should introduce a Repaint boundary. The more advanced thing is timeline debugging. So in profile mode, it only works in profile mode and it only works in on real devices. Oh, that's one thing. If you build in profile mode or release mode, you build for real devices. Don't try to debug for performance issues on real devices. So when you launch on a device, there'll be a local server which you can go to, and it's going to be lots of debugging information, but there's also going to be a timeline inspector there. It's, I think, there's some redesign going on for this, but it looks ugly right now. But you can actually use that timeline inspector to see all the calls that have been made, both on the UI and the both the UI and the GPU thread, but you need to press something for GPU thread to be debuggable. You can see sometimes it happens. So there's a frame, which is this part of the UI that does building. So there's some build stage, there's a layout stage, there's paint stage, there's some other stage here. And you can debug visually if some of the widgets, for example, take long to build. And you can, of course, add your own things to the timeline. Of course, it only makes sense in synchronous operations. So if you do asynchronous operation, it's happening sometime, somewhere, and possibly whatever you measure is not going to be performance of that function. So if you have some synchronous operations going on, you can put it like this. Filip Hracek had a nice talk on Flutter Europe about this. I think it's going to be available like in a week or so on a Flutter Europe channel on how to actually work with timeline. And you can see it's not very easy to use, but it might be useful. Oh, that's it. Thank you, I guess. So yeah, that's my website, that's my Twitter handle. If you want to know more, I'll stay around for a pizza and beer, so we can chat. And yeah, enjoy. Oh yeah.
You show us there's plenty a bunch of tracks in debug mode. Are they default enabled?
No. These are all disabled because these print like let me go back. These print a lot of information. Normally you don't see this, but it would print, oh, the new frame is going on. Like a new frame is where the vsync comes, and there's actually anything to rebuild. And you say, oh, the new frame is, I'm starting a new frame, new frame. Only if you start the app, you'll see like 2 or 3 frames just by default, because that's a warm up, and you possibly create some first element, maybe it updates its state very quickly. And if you use the app, it's going to be a lot of information. So it's probably better to just dump it into a log file somewhere and process it later on. But yeah, if you have a debugging mode, and I don't know, you press a button and you suddenly see lots of information in unrelated widgets, this might give you some hints. But as I said, these are very verbose. So yeah. I did it once because I needed to debug there was one bug in one widget Flutter that I needed to debug, and this is a hard time without these tools, because it's somewhere out of your control if there's some bug in a Flutter SSDK widget, right? You need to figure out why, what, how. Yeah. Yep.
I'm not so experienced, but a method of mounted
Yeah.
that method. It was somewhere in examples in source code. I know it's useful to take care if it's widget mounted when you do some async calls or something.
Yeah.
But should I care about anything else except of this?
Frankly, not much. So anything else is usually going to be triggered by the widget. So if I press a button, I don't need to check just after the button is being pressed if it's going to be mounted. So UI happens in a single thread, right? No, it's just one thread. So until we do asynchronous functions, there's no chance that pressing a button and calling a callback will happen a different thread and will be separated. Sometimes this can happen because widget that's about to disappear, somehow you manage to press it, but it's not something you should care. What you should care is that if you, for example, press a button, the button triggers some async operation, like I don't know, like this, like my present. Oh, yeah, put a like on Facebook feed item, and it needs to receive a data from a server. If it actually has received that, and everything's okay, and then it wants to refresh or like, say everything's fine. Then you should check that. Like if you have asynchronous operations outside of this, it might happen, but if it does happen that you try to do something on a mounted widget without asynchronous operations, it's possibly nothing important because it's not supposed to be there. And if it happens, nothing bad will happen, hopefully, if you try. Because Flutter does these checks, and it basically will tell you, well, no, thank you, I'm not going to do anything. It's not going to crash as well. You had a question.
Yes, because you mentioned about the expensiveness of render of objects, and I wanted to ask, so as far as I understood, it's better to use LTRB padding if I just want to, instead of doing left padding and right padding separately, for example.
So using one widget instead of multiple widgets. So if you have paddings, all four of them, you don't want to insert 4 padding widgets into that tree because it's going to create 4 render objects, and each of the render object is going to calculate the size of its parent, actually say, okay, I just want to add something here. It's not going, in case of padding, it's not going to be very expensive, but these are patterns that you should avoid in general. Like if there's something like one padding is one render object. One padding widget is one render object.
So even if I want to like have 2 paddings, left and right,
yeah.
I should use LTRB.
No, LTRB. You can use only left, right. Yeah. I mean, LTRB and only are the 2 options if you have very custom paddings or symmetrical, whatever floats your boat. Or only. Yeah, not to create more widgets than you need to really. I mean, try use shorthands. Of course, we say, oh, we create just 4 paddings in one place. But what if this is just in one element that you reuse all over the app, right? It's going to have a little bit of impact. But in case of paddings, it's case of some, I don't know, more I think of maybe border. If we create, instead of like one border, we create separate borders for everything. That might be more heavy on a GPU, because what we actually do is say to GPU more canvas operations need to happen, right? Yeah, but yeah, that's a detail. Just to know that, hey, yeah, just to know that, be cautious of what you use, like how does it work. As I said, container doesn't do this smart, it just cascades different widgets on top of one another. But padding is a render object widget, so it has a render object, and every widget we create is one object. Okay. Any more questions? Yeah.
Yeah, you mentioned that state is a lie.
Yeah.
It's kind of like is stateful widget also a lie?
So stateful widget isn't a lie, but there's not huge difference between stateful and stateless widgets.
So what's the difference?
Stateful widgets can rebuild themselves. So they have some autonomous state, let's call it. Right? And what happens, I told you about this update thing. Let me go back. This is... Oh, maybe I go to the very beginning. So what happens when a new widget gets replaced? Like, let's say this is a stateful widget, here, the blue one. And this is an element created from a stateful widget. So what happens when a new widget comes is actually the new widget gets here. Maybe it gets this element gets updated with a new widget, but the old state that was created is reattached to that widget object. So the state itself can move even if a widget changes. And there are some, there's this didUpdateWidget method in state that's actually there for checking, oh, should I reinitialize some fields because my widget, my configuration changed. So that's a difference. Apart from this, really, there's also this misconception, for example, that stateless widgets rebuild only once. And as I shown later on, wrong direction. As I shown later on, not this. When we inherit from inherited widget, that inherited widget is going to trigger rebuild of that stateless widget. So this stateless widget can rebuild multiple times, possibly lots of times. But the difference is it doesn't manage internal state internally. The state, the data it needs is somewhere else. So it's yay! Everybody wants pizza, so quick. That's the last one, so we can. I also can have pizza.
Actually, that's the right screen. Is the point of diminishing returns using this method? So we actually get the data in the super parent, right? And super parent, as I understand, we just call the build method that we will rebuild the stateless widget. Is there a point of diminishing returns in the, because this is a dictionary hash method, as I understand.
Yeah.
Is there a point that this will slow down if you ever noticed it?
If you ever what?
If this actually will, if this method at some point will become alive.
Of course. I mean, this is what I said. So if we do that inherited widget thing, thanks, smart devices. Then it doesn't discriminate. If you use part of the data it provides, it doesn't matter. It will always trigger rebuild if it determines it changed. So this is where it can go wrong. But does it answer your question?
Maybe.
Yeah, maybe we can do it offline.
Yeah, with pizza.
Yes.
Yeah.
Okay. Because we have a contest. Quick swag contest right now.
We have a contest. Thank you. Yeah. Okay, thank you again.